Hello everybody, I'm Nigel Forrester and I'm here representing Concurrent Technologies. We are a UK-based manufacturer of predominantly Intel-based processor boards for the deeply embedded applications. And I'd like to thank Jerry for coming up with The Future Is Now as the sort of conference title. Gave me lots of scope with our presentation today, and I'm going to present what I think is Back to the Future. So, for those of you, I suspect most people know that Back to the Future, feature-length films, starring this character, Marty McFly, initially goes back in time, and then there's a sequel where he has a hoverboard, and he's sort of balancing, in his case, he goes forward. In our case, what we're sort of doing as an embedded computer board supplier is balancing, on the one hand, those really legacy things that we have to do with all the really great futuristic things that we need to bring into the platform. And some of those things sort of pull you one way and sort of nearly overbalance you, and the same the other way, and actually they're quite difficult to get together. So that's what we're going to cover today in the sort of presentation. A couple of instances where I've picked specific ideas where we're sort of developing our product line and how we're doing that, but based very much on sort of what we've done over the last year. So I'm using as an example one of our VME boards that we introduced last year. So obviously many of the people in the conference are talking about sexy, shiny, new objects. VME, by contrast, is old technology, really. It's been around 20, 25, 30 years. And on that legacy side, you've got the VME bus interface, you've got things like PMC support. In our case, we've defined our user I/O pins, and we have many generations of customers who want to plug in a replacement board. So we have to do a lot of backwards compatibility things, even to the extent, in some cases, of going back to sort of 3-row connectors. But on the other hand, we, as a provider of Intel single-board computers, we want to give you the best possible compute experience. We use processors from the embedded line of Intel, and until a couple of years ago, they guaranteed a 7-year life cycle with those processors, which was good, but then they changed that to 15-year life cycle. So there's great need, really, for us to be using and delivering a customer experience based on new generation processors that we can offer better life cycle on. So our product, the VPB7X product that we introduced last year, was based on a 6-core, formerly known as Coffee Lake processor, which is sort of from the main line of the Intel embedded line. That has what's called a UEFI BIOS, and I'm going to talk a bit more about that in a minute. And it also offers the possibility of very high-speed storage. We have on this board one M.2 module site, sort of down here on the board here, if I can get the pointer sort of somewhere in the right place, that gives you the ability to theoretically store data, read and write data at up to 4 gigabytes per second, which compared to the sort of rates that you could store data on previous generation modules is huge, really. So it opens up new possibilities. And the other thing that I'm going to talk about in the second half of the presentation is enhanced security. So if I'm putting myself in a position of listening to sort of, I'm trying to develop the requirements for these new boards, the sort of questions that I get from customers are typically these sort of things. And I guess many of the people in the room will have heard of similar requirements. You go meet a customer, and what they really want to do is they want to keep running the same application code that they've been running for many years. In some cases, that's because their development team are busy on other things. In other cases, it's because the development team doesn't exist anymore. And to a large extent, it's because they know that application works, the risk-averse type environment that we work in. Why would they want to change it and break it? And the same thing, because they're running the same application, they can't change the operating system or version, and they still want the ability to use open standards. Oh, and by the way, it just sort of slips into the conversation, but I want the latest security gadgets and capabilities and features. That's sort of quite tricky, because that might be mutually exclusive. But nevertheless, that's a good requirement. Oh, and they also sort of drop in that, well, we've got to keep this running for, 5, 10, 15, 20, you name it, really. And when I sort of first heard these sort of requirements, I was thinking, well, that's pretty unrealistic. You're asking for the world, but then you step back a bit and you put yourselves in the position of the customer and actually think, well, no, that is totally reasonable. That is what they've got to deliver on. So isn't it incumbent on me as a vendor of these types of products to meet their requirements? So whilst it's not easy, that's what we're good at. That's what we should be good at, because that's the reason for us existing. And if I just step back one more step, on the one hand, you might think, well, because we major in Intel-based processor boards, all this is really easy because Intel x86 is backwards code compatible. It can run the same things that you did on your 286, 386, 486 Pentium, Core 2 Duo, etc. And to a large extent, that is true, but there are now some restrictions or some things which make it a little bit more difficult. And one of those is the UEFI BIOS, or the BIOS migration. So it's starting to get a little bit more technical, but about 10 years ago, there was a move to update the BIOS, basic input-output system, which is the sort of core firmware that all PCs run. Initially, it was what's known now really as legacy BIOS, but it was known then as just BIOS. And that was sort of it had grown, it had lots of serious restrictions in terms of the scalability and the extensibility, and there were some significant security concerns. So the answer to this was what's called UEFI, and there are various classes of UEFI, and we've been working towards Class 3 for probably about 10 years now, through successive generations of product. So I guess Class 1 and Class 2 UEFI products have been in the market for a long time, and they are a good step forward, but they still include the legacy BIOS, and they still include what's called the compatibility support module. Class 3, UEFI Class 3, we now have some processor boards, and that VPB7X is one good example, that is only UEFI Class 3. So there is no legacy BIOS. And what that means is that you cannot now boot one of your old legacy operating systems. So, and by legacy, I don't mean that old. I mean even things like Windows 7 is treated as a legacy operating system. So you can't boot any 32-bit operating systems natively. You can't boot DOS. We ourselves had many DOS test tools that we've had to migrate to overcome that. So if you put yourself back in your position of the customer who's got an application that they've been running for 10 years, that will be booting on a legacy operating system. So how do we get around that issue? So one solution is that you actually boot what's called a hypervisor. And that hypervisor could be what's known as a bare metal hypervisor, i.e. it's just a hypervisor, or it could be part of a hosted hypervisor. In other words, it actually is an operating system that includes a hypervisor. So some versions of Windows include Hyper-V, which is a Microsoft hypervisor. A bare metal hypervisor, a good example of that is VMware Esky. So it basically just boots the hypervisor, and then what you do is you run your legacy operating system and application in what's called a virtual machine. So that's easy to do. It's relatively straightforward, providing your hardware supports the virtualization hooks. And in practice, we've done some fairly extensive now testing on using virtual machines and hypervisors, and the performance impact is quite minor. So for a hosted operating system, we see, if you want me to put a figure on it, roughly 10% performance impact compared to running it natively on the hardware itself. If it's a bare metal hypervisor, we typically see between 1 to 3% performance hit, which is very small, especially as the modern processors, that 6-core Intel processor that I was talking about at the start, its core clock speed is 2.7 gigahertz, and it can turbo up to 4.4 gigahertz if you really want to. Compare that to maybe the processors that you were using 10, 15 years ago, which were maybe under a gigahertz. It's quite, there's plenty of performance there, so that's not typically an issue. However, when we dig in a little bit further, there are some other things to consider. So the really good thing about virtualization is that some of the interfaces, gigabit Ethernet being a good example, the actual hardware device that we're using on the boards supports what's called single root I/O virtualization, or SRIOV. And what that really means is that from a single physical device, each virtual machine can access that interface. So each of your virtual machines can actually access that Ethernet interface. That's not quite so easy with some of these legacy interfaces, though. So VME bus being a good example. The VME bus interface chip doesn't support SRIOV. So in this case, only one virtual machine can actually access that interface. And that's working in what's called a direct path I/O mode. So there's a couple of use cases where, whilst probably acceptable in some cases, if you just want to run one legacy operating system and application in one virtual machine, maybe you might want to consolidate what you have on 6 VME boards onto one new high-performance board running in 6 virtual machines. That's fine, providing you only want to access the VME bus from one interface. So what we're looking at doing is extending our VME bus driver and capabilities so that potentially in the future we can actually support multiple VME bus interfaces, for example, in this type of environment. So lots of good, interesting work there to keep that backwards compatibility, but using it on a very modern board. I think I showed this slide at last year's Embedded Tech Trends, so I want to sort of talk a little bit more about security, and one of the other speakers gave a really good high-level view of some of the security capabilities that are being asked for and architected into the solutions. So as virtue of being based on Intel hardware, we have some good things that we can leverage, and security is one of those things that it's not a point in time where there's a single solution. It's a journey, and we're on that journey, and some of the things that we're doing are quite sophisticated, some of the things are quite straightforward, but security is that you have to look at the bigger picture. So everything counts when you're looking at security. So one of the things that we were talking about last year, and some of the speakers have picked up on, is that sort of root of trust. So everything builds on everything else. So in our type of environment, when you power on and the board comes out of reset, the first thing that happens is that the bootloader starts to boot based on the firmware that we've programmed onto the board. Okay? And at every step of this process, you can actually measure or take a measurement and record that measurement in the TPM, the Trusted Platform module, so that you can go and remotely decide whether you're actually booting the right device. So once you've booted the firmware, for example, then you might want to boot your operating system. And there's a very nice way of doing what's called secure boot, where the operating system image is actually has a private key. So if you source a version of Microsoft Windows 10, that has a specific private key that Microsoft embed into it. And you can check that private key against a public key and make sure that you are actually running the official Windows 10 image. And if not, then obviously you don't boot. So that's, it's not just a Microsoft feature. It's something that we enable if you're a customer and you want to build your own image. We have key management capability, so you can take out the Microsoft key and put in your own private or public key into the firmware and make sure that you're booting the right operating system. Once you've got that trust, then you can boot your application, and maybe there's multiple levels that you can do. And if you want to, you can actually go read those values out of the TPM remotely and what's called a test that they are the true values. And that's really good. But obviously, it's only a measure of what's happening. And the key thing here is that the first part of this chain, the firmware, maybe we need to look into that in a little bit more detail. So what we're really talking about is end-to-end security. So here's our factory in the UK down here. We know, because of the processors that we use, that the firmware we're loading onto these products is trusted firmware. When the boards are delivered to our customers, they also have very good, strict processes about how they manage their operating systems and applications and all the things that they do to move boards into secure areas and not bring them out of those secure areas unless they're sanitized and so on. However, one of the really easy things that many of our customers have been worried about for a long time is that once we ship the board, we actually send it on a standard carrier, pretty much. Sometimes our customers even arrange that themselves. So we have no control over what happens to that product once it leaves our secure facility until it gets to the customer's secure facility. How do we know that that board hasn't been tampered with? Pretty unlikely, but the thing about security is the unlikely sometimes happens, okay? So any break in that chain is a security risk. And the way that we are now moving forward in that is that we have implemented what's called Intel Boot Guard. So again, this requires a private and a public key. We sign our firmware with the private key, the Concurrent Technologies private key that we've assigned for that product. And then during the manufacturing process in our facility, we actually fuse the public key to that board. Okay, and that is a one-time only process. That fuse cannot be overwritten, it cannot be undone. You'd have to remanufacture the board to replace that key. And then any attempt to boot non-authorized firmware will result in the board failing. In fact, it will fail to boot. And the way we've implemented that is we've implemented what's called the immediate shutdown mode. There is a separate mode where you can actually run for a certain length of time before the product shuts down. But we've decided that in our type of typical customer environment, it's better to shut the board down immediately. Still enables us to do maintenance updates because we can supply the customer with new firmware images. We just have to make sure they're signed with the right private key. And we also have some mechanisms in how we get those images to customers, which might be a good topic for a later discussion. So the reality here is that what we're trying to do is ensuring that the firmware has not been tampered with, and that might be before it arrives at the customer's site, but it's also, very importantly, during the life cycle of that product, because who knows where end products get shipped to. Quite often things are in racks and they're wheeled around on tarmac and left unattended. So all the time you're trying to look for those gaps in the security, end-to-end security environment and see where they are. We're going to continue that balancing act. We're sort of still very much interested in supporting those legacy features, but at the same time we want to make sure we bring in the best and the most fully featured products that we can. And if we think back to the mid-90s when William Perry made his definitive memo really about using COTS equipment, I think largely that sort of ethos, there is a goodwill to develop and deploy COTS equipment, but as a COTS vendor, it's part of our duty to deliver on the promise of sort of keeping those military customers happy. So we sort of treat that really seriously. And that's not something that you can just do as a point thing. It's a continual process, but everything about the way we work is trying to make that happen. Okay, so that's all I have today. Thank you.